Thank you. Thank you, Professor Sudha, and all the students and the faculties who have joined. Hope my audio and video is clear. Suppose, can you click raise hands if you're able to see my screen? Is my screen, or you can post your answers on the chat? Is the screen visible to you? Yes? Thank you. So today we are going to speak about machine learning algorithms and applications. Once again, I'd like to thank the entire management of Vellore Institute of Technology for having invited me to this session on machine learning algorithms and applications. All right, so I hope this session will be useful to you, what you're going to learn, and how you'll be able to apply it on your portfolio, right? Before we start, may I know which department you belong to? Answers on chat, please. Can I give you your answers? I can see like almost 50 people here. Which department you belong to and which year? Can I give your answers on chat, please? Yes. Whether have you all received my chat? Good evening, everyone. We want to have the session to be an active session. Ma'am Sudha, ma'am, I'm just typing hello, whether you're able to receive on the chat. The students, can you kindly post on the chat which department you belong to and which year of course you are into? Yes, please. All right. Hope my audio is okay with the students. I'm getting a response from Sudha ma'am. What about with the students? We have got 52 participants. Like Pratik Agarwal, whether you are able to receive my chat, can you respond please? Pratik? Once you respond, it will be easy for us to have an interactive session. Anyone, can you share which department you belong to, or just post any message onto the chat to let me know whether you are receiving my messages. All right. All right. So let's move on to the session. Sudha ma'am, can you just ping me a message so that I will know whether I'm receiving messages or not? Yes, please. No, I'm not able to. All right. Hmm, I'm not able to get it. All right. So in today's session, we're going to see about machine learning algorithms and applications, right? Machine learning algorithms and application. So, what are the? Can you? Because we are not able to connect with the chat. Let me ask you a question. What are the applications that you've developed still now with machine learning? Can you feel free to unmute your mics and speak? Can one of you? Yes, please. Any applications? Hello, ma'am. Hmm? Okay, so they'll not be able to interact. It is not listening. I'll check once. Okay, 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 okay. I will just pick. Okay, 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 okay. All right. So, So today's session, we're going to see about machine learning algorithms and applications. All right. What are the different packages that are much mandatory needed to develop a machine learning model or machine learning algorithms, right? So the first package that we're going to see today is NumPy, which stands for numerical Python. A lot of mathematical computations that we can do, we can use the package NumPy. All right. Second package, Python package that we're going to see is known as SciPy, which stands for scientific Python, right? Which stands for scientific Python. So and scientific Python, scientific computations would be we will be able to access accordingly. And Pandas, Pandas stands for Python for data analysis. How are we going to first take your data? How are we going to analyze the data? Is that we are going to see first, all right? And then moving on to having our data is not only important. How are we going to visualize the data, right? How are we going to visualize the data? How would it be usable to get insights or to get inference from those details, right? And then we move on to Seaborn, that's another visualization package. And then we move on to evaluation of algorithms. Then we move on to evaluation of algorithms. All right. So these are the major topics that we are going to see for today. So starting with artificial intelligence, all right, when you take artificial intelligence, can you give me an example of artificial intelligence where it says about machine is able to carry out tasks in a smarter way? It's like anything that enables the computer to behave like humans. Can one of you, I don't know what is the issue, can one of you unmute your mics and tell me one example that we see in day-to-day life on artificial intelligence? Yes, please. Can you unmute and speak? All right. So different kinds of, like if you take Alexa, right, or you use your normal Google Assistant, all right, wherein you'll be able to make your task where as human we can do, but the system will be able to make it even more smarter, where the systems are making smarter. So that's what, then listen to the session very carefully. At the end of the session, we are going to have a live quiz where we'll see who is the winner of today. All right, so when you take artificial intelligence, there are different types of artificial intelligence also, where the system is able to do the task in a smarter way. It trends to behave like humans, right? When you take a Google Assistants or Alexa or Siri, right? All these kinds of applications, when you take, all right, you'd be able to figure it out. What it works for the predefined comments and responses. All right, so the predefined comments and responses are the ones like that we work with weak AI, right? And then we move on to strong AI. How many of you knew about Sophia the robot? Can you give a click? You can raise hands or you can give some react. I don't know. I don't know why the chat. Yeah, thank you, Aish. Yeah, I could see some of you are raising hands. So this is a good way to me to interact. All right. So yes, thank you, Abhinav. You know, right? Sophia the robot, right? So I think I could get 5 out of 66 attendees have clicked raise hands, right? And here it is an example of a strong AI where without giving any predefined responses, Sophia, the robot that is designed to enhance in robotics, it is able to present itself, right? For questions, it processes and gives us the answers, right? So those kinds of artificial intelligence moves on to strong AI. And some other examples of and also the self-driving cars, right? The self-driving cars, these are examples of strong AI, right? Where it senses is there a car coming, and then it tries to move, and then it takes, if it sees a U-turn, it takes a U-turn. It does things on its own, right? Those kind of applications, for example, Sophia the robot, the self-driving cars, they all come under strong AI. Without predefined commands and responses, they are able to work on their own. And the third sector that we are going to see is called a specialized AI. Right, a particular AI is able to compute a task on its own for a particular task. For example, if you're going to see painting robots, right? If you're going to, I don't know whether you've seen painting robots. When you see painting robots, you give the structure of the rooms, right? The hair, the length, the width. Is there going to be a window or a door? All these structural components are fed into the robot, and within few minutes, with like 1/10 time of how a human can, or even 100, we can tell, it completes the task very fast, right? With the predefined, gives the structures of that. For example, if it is painting robot, if I give you the structure, then it takes the structure and then uses the painting brush to complete this task very fast. All right, so these are the three, basically these are the three types of AI, right? First is a weak AI, then we go on to a strong AI, then we move on to a specialized AI. All right, is it clear till now? Yes. All right. Then moving on into your machine learning, right? So when you take machine learning, it is a subset of AI. The whole set is artificial intelligence. The subset of artificial intelligence is machine learning. The subset of machine learning is deep learning. All right. So when you take AI, machine learning, you give access to the data and should be left to learn and explore themselves. One basic word that you should mandatorily understand is extraction of data patterns or learning different data patterns. Right? How are you going to learn the data patterns? So machine learning algorithms are such, it is not working with predefined comments and responses, rather you give a set of data and from the data it tries to learn, you give an option to access those data and the data tries to learn from it and then it then it is able to explore and give functionalities accordingly. All right. You bought some products in Amazon. Yes. How many of you have bought products in Amazon for the past 1-2 months? Can you click raise hands or can you give a react? Yes. Click raise hands whether if you have bought any products in Amazon. Yes. Is Karthik Verma has clicked raise hands. Yes, so many. Yes. I'm typing your messages. Are you getting it? I don't know. Just I'm trying it out whether you're able to get messages. I'm not able to figure it out why the messages I'm not able to. All right. So I can see set of people who have brought products in Amazon, right? When you buy products in Amazon, all right, you see you buy products in Amazon and you don't get it as such, right? You see to it and then you find it out, then you see the reviews of it, right? And then you go on what is the ratings that has been given, and then have you seen customer who viewed this product has also viewed the list? Yes, no, right? You would have seen it, right? The customer who has brought this product has also seen this product. So you jump into it and then see. That is an example of recommendation system. Say, for example, if you're going to buy a product, you search, and after a week, you go and search for the same product. You will see the customer who viewed this product has viewed also this product will be something different. All right, be something different because machine learning is one you give access to it and for every click that person does, right, for a particular product, say for example if it is mobile or speaker or keyboard or whatever may be, right, whatever may be, when you see to it, right, when you see to it, they find it out after the next week. If you're going for the same product and see, you will see there will be a change in it, right? You will see a change in it because every click per view by user, it learns from it and it enhances your recommendation algorithm. Able to understand the difference between artificial intelligence and the subset of artificial intelligence is machine learning, where you give access to the data and they try to learn on their own and to compute its task. All right. So when you take what is machine learning algorithms that parses the data, learns from the data, applies what they have learned to make informed decisions. All right. So this is what is artificial intelligence, sorry, machine learning means. It has got a lot of algorithms, machine learning algorithms are wide, and we're going to see the core part of the different algorithms in today's session. All right, algorithms that parses the data. So if I'm going to give you a data, it parses the different data and learn, say for example, if it's going to see the same example, if I'm going to take an Amazon, right, recommendation system, what product? First, it parses the product, whether it is computer or dress or speaker or whatever it is. It has got multiple classifications there, and then it learns from the data what particular product. All right, and then it makes to make informed. It is just people come and simply search and go without buying, or in reality, are they going to buy it? And was the product useful for them? What was the review given to them? So many parameters will be taken into consideration. All right, able to understand. I hope you're also learning about, I'm sure that you're learning this course on machine learning. First, any machine learning algorithm, it parses the data. Step 1. Step 2, it learns from the data. And step 3, it makes usable information. For example, when you see, I gave you an example of Amazon, right? The Amazon breakfast, right? And then if I'm going to take YouTube, you all see YouTubes, right? You all see YouTube. In YouTube, when you see a particular product, right? When you see a particular product, whether you have seen that, sorry, when you're going to listen to your music, right? When you're going to listen to your music and or video, can you see the same kind of videos are being bundled onto the right for your next recommendation? Yes or no? You are watching a video in YouTube, and say for example, if you're watching cricket, can you see the related cricket videos bundled up onto your right? If it is yes, can you click raise hands? I hope everybody, right? We have got 80 people here. I hope everybody you are using YouTube. At least you should have used YouTube once in your lifetime. Have you seen when you watch videos of the same genre of videos you could see on your right? Yes or no? If it is yes, click raise hands. Is my question clear? Yes or no? Yes, please. Yes, please. All right. Is my audio clear? Is my audio clear? Whether you're able to hear? Okay. And as we move on to the next, right? So Python for data analysis, right? Well, I told you, right, the package pandas, it stands for Python for data analysis. What are the computations that you can use it in pandas, right? What are the computations that you can use it in pandas? You can select, you can filter, you can manipulate, like sorting, grouping, rearranging. If you have got two different data sets, you can join the different data sets, right? How are you going to read? And when you want to read your data could be in any form, right? Maybe a CSV, a comma separated value, or a tab separated value, or else it could be an Excel file or a Hadoop distributed file system, all right? And then whatever it is, that could be taken and that could be loaded onto pandas, right? That can be loaded onto pandas. We will see how the data type changes after we load. And then you can plot the data. For plotting, we use Matplotlib or Seaborn. For descriptive analytics, what is this data speaking all about, right? How we are going to that? We are going to work with exploratory data analysis, right? We are going to work with exploratory data analysis, and then eventually we'll be moving on into inferential statistics. So what the different Python packages I told you from the start: NumPy for numerical, SciPy for scientific, Pandas for data analysis, scikit-learn. This particular package has got a bundle of machine learning algorithms. This has got a bundle of machine learning algorithms. And then moving on to your visualization libraries, that is Matplotlib and CPAP. Right. So what NumPy is, we'll see what NumPy does, right? Here we can work with multidimensional arrays and matrices, right? And it performs advanced mathematical statistical operations on those. Whatever the mathematical being, maybe the Laplace series, Laplace transform, Fourier series, Fourier transforms, right? Differentiation, integration, all these can be computed using NumPy and SciPy packages, right? They provide vectorization of mathematical operations on arrays and matrices, and here it improves the performance of it. And this is the website. Alright, I hope NumPy screen is seen to you, right? So this is the NumPy package, right? The scientific computing packages. I told we can work with different environments. N-dimensional numerical computing, right? And also you can work with quantum computing, statistical computing, signal processing, image processing, for graphs and networks, for astronomy, cognitive psychology, for geographical, geoscience, for chemistry, all right, for mathematical, for Bayesian inference, so much and so more, all right. So this is the package. What are the different applications? Like using this package of NumPy, you have got a wide range of applications. It all resides in what problem definition that you're going to take. And then moving on to the next package called SciPy. All right, in SciPy, you've got collection of algorithms for linear algebra, Z-led differential equation integration, and this is the package, right? So SciPy, it has got algorithms for eigenvalues, eigenvectors, differential equations, all right, and it has got wide range of applications where you'll be able to work on with it, right? Where you'll be able to work on with it. So these are the basic two packages that we are going to use for the scientific computations, right? For the scientific computations. All right. And SciPy is built on NumPy. So whatever you do it, SciPy is built on NumPy. So whatever you do on this can be done on the other two. Then moving on to the next package called Pandas. It adds data structures. Listen carefully. If I'm going to have any data, right, even it could be a CSV file or an Excel file, listen very carefully. Once I load the data set into Pandas, all right, the type of the data changes to the data frame. I repeat it. I have any kind of data set could be uploaded into Pandas. But once I upload my data set into Pandas, that is Python for data analysis, the type of the data changes to be data frame. All right. So using the data frame, I can reshape, merge, sort, slice, and aggregate. And also it allows to handle missing data. Listen very carefully when you're going to develop a machine learning product or machine learning algorithm. Your data set here in our research foundation, we have worked even the maximum with 1.2 crores of data. Right, and when you're going to work with these, all right, and the number of rows and columns, like a multi-dimensional array or a single, whatever it's two-dimensional array, you should not have even one single missing values, right? You need to know what are the different missing values available, what does the missing values do, right? All right. And then, all right, and if there is missing values, you will not be able to develop your machine learning algorithm. Yes. Whether you're able to understand till now? Yes or no? All right. See, I'm going to take a data set of this is what's an analysis data set of sales and one. I'm importing two packages, pandas for analysis and data visualization seaborn. All right. And I'm going to load this data set, CSV data set, right? So when I'm going to read, can you see? I am reading a CSV file, but once I load it into my pandas, how I imported? Import pandas as PD. Once I imported as PD dot read underscore CSV of URL, the data type changes to data frame. Able to get it? This is what I said. So any data set, once I, even though it's a CSV file, once I load it into my data, once I load it into my pandas, the type of data changes to be data frame. Yes, able to understand till now? We have 59 participants. Can you click raise hands whether it is clear till now? Yes, no? All right, I understand that you are sitting in a common hub and then responding from each is difficult. All right, okay. And then moving on to this, right? So this is how I said whenever you take your data, it moves into your data frame. So scikit-learn package is one of the most important packages for your machine learning algorithms, right? Here they provide different algorithms for classification, for regression, and for clustering and model validation. As we move on to the session, we'll be seeing in depth about classification, regression, and clustering. And this is built on NumPy, SciPy, and Matplotlib. Remember when I said SciPy, it is built on top of NumPy. But now when you say scikit-learn, this package, this Python package, where you've got bundles of machine learning algorithms, right? Where you've got the bundles of machine learning algorithms. Here, it is built on top of NumPy, SciPy, and Matplotlib. All right, NumPy, SciPy, and Matplotlib. All right, and the next package that we are going to see is Matplotlib. Okay, Matplotlib is a Python 2D plotting libraries where it provides the how you are going to have different kinds of charts, right, or histograms, right, heat maps. So much and so more, like line plots, like scatter plots, bar charts, histogram, pie chart with the data set, and related it's a low level interface for visualization. The next higher level interface in comparison with Matplotlib is CBOM. Right, it's got attractive statistical graph. There are still more visualization packages like bokeh. All right, so much and so more packages. They are like higher level visualization packages are available. If you're free, sometime you can visit my YouTube channel, Doreen Robin. I've given series of lecture of what are the different data visualization Python packages and for what application it could be used. All right, and for what application it could be used. So today I'm going to show you the demonstration with the Colab of Google's Colab. So I told you I've taken a data set, I've loaded into my, it's a CSV, I have used it. Is the notebook seen to you? Is the notebook screen seen to you? Can one of you click raise hands? Or one of you can unmute and say whether you're able to see the notebook. Yes, no? Ma'am, is the screen seen? Colab screen seen, ma'am? Okay, that's what I'm waiting for the response. Because right. So here I have imported the CSV file and it changes to be a data frame. So when I'm going to give, I'm importing everything into this variable called sales underscore data. So if I'm going to give sales underscore data dot shape, it's a pandas attribute. All right, it shows me the number of rows and columns. We have like 78,000 rows and 19 columns, right? And 19 columns. And when I have a parenthesis here, it is a method. If not, it is an attribute. All right. So if I'm going to give the head of, see, I can get the first few rows of it, right? The first 5 rows. Say, for example, if I'm going to give a value 3, default it is fine. I'm going to give value 3, then I'll get only 0, 1, and 2. All right. So what is opportunity number? It is almost, this data set is almost, it's about the car accessories that is sold to the market. All right. So whether it's an exterior accessories or what is a non-performance, I'll tell you how when we go for Unix, so which region of US it has gone to the market, how this particular product is routed to the market, how many days it was on the sales stage. This is my target opportunity result, whether the particular sale is won or lost. Right? What are the sales state change count, right? From the inquiry, how it has moved through identified through closing, through identified through qualified, right? And then here you can see what is the amount and client size by revenue and the ratios and so much and so on. Whether they are the old client or a new client. So my objective in this developing a machine learning model in this, with these features, my target whether my opportunity is going to have win or loss. All right. So, but listen carefully. I told you when I take a CSV file and when I load it onto my pandas, it becomes data frame. Listen very carefully right now. But the values inside my data frame is of type numpy array. I repeat, when I take a data set, any data of different types, a text file or a CSV file or a TSV file or an Excel or a Hadoop file or a SAS file or whatever it is. Once I load the data set into my pandas, it becomes data frame. But one thing I want you to understand, but my values inside my data frame is of type numpy array. Able to get it? All right. So it is of type numpy array. So you can start either using Jupyter Notebook, which comes with the Anaconda, or I'm using here Colab. So what are the necessary packages we can import? So here I can give a direct CSV file. I want to have an Excel file. I'll give read underscore Excel, stats data, then understata, a SAS file, a Hadoop distributed file system file, right? All right. And then moving on to, I've showed you these things, and then we move on to different kinds of learning, a supervised learning and unsupervised learning. All right, a supervised learning is what? You have a target value. You have a target value. Say, for example, if I'm going to take the list of apples, right? I'm going to take a data of apple. I know my target is an apple. So it goes to a training data set and then I give an algorithm to train it. It processes it and then I get an output. And for my testing part, I'm going to give the green apple. But still my ML algorithm will find it is an apple, taking in case of its features and the data patterns. Right? Any application, listen very carefully, any application that has a target value. If I'm going to take your exam results, the target is pass or fail. If it is a health data set, whether the particular patient is going to have the particular disease, a diabetes or not, or a heart disease or not, that comes under supervised learning. Or voting, which party is going to win or lose. All right. So any application that has got a target value, then we'll be applying supervised learning. Where applications that you don't have a target, then we go for unsupervised learning. Right? So when it comes under, listen carefully, when it comes under supervised learning, you'll be working with classification algorithm. You are classifying. Either you can go on for a binary classification or you can go on for a multi-classification, multi-level classification. How do you say in a class whether we have above average, average and below average students? All right, or if you take disease level, right, heart disease, no heart disease, level 1 heart disease, level 2, level 3, level 4, there you'll be applying multi-level or multi-class classification algorithms. If it is binary, then we use binary classification. Wherever you have a target, you go on for supervised learning. That comes under classification. When there is no particular target, then you go on for unsupervised learning. Say for example, when people go for malls, right? When people go for malls, right? They don't have a particular target. Some goes for shopping, some go for just for time pass, some goes for movies, some goes for food, and so much and so more. When there is no target value, then you'll be applying unsupervised, no training data. It learns the data patterns. You remember I told you machine learning, it learns the data patterns and then it classifies. There are a set of apples, bananas, and mangoes. So when an algorithm in machine learning is a procedure that it runs on data to create machine learning model. All right. So here it performs a pattern recognition. Right. What is this pattern all about? And learns from data and fits onto the data. All right. There is something called product fit and product market fit. Whether I'm telling students now, do not think of developing projects, think on developing products, think on developing products so that you will be able to use it, right? It will be usable for people in this world. There are many machine learning algorithms. For classification, I told you, right? Like k-nearest algorithm. For regression, linear regression, right? Regression you apply when you have like continuous change variables, when you have a continuous change variables. All right, examples of machine learning: linear regression, logistic regression, decision tree, artificial neural networks, k-neighbors, and k-means. What is a model in machine learning? All right, a model in machine learning is an output of a machine learning that runs on data. Okay, that runs on the data. So you give a data and it keeps learning from the data and then it eventually responds to it accordingly. What was learned by a machine learning algorithm, right? So that is safe vector learning. That's what I told you, right? In the initial example, you remember, once you buy a product in Amazon, you see customer who viewed this product has also viewed the above product. And then after a week or after a month, if you're going to see that, then the products would have been changed because it is a continuous process of learning from the behaviors of the data that has been accessed by the people. And that is an autonomous algorithm. All right. So an algorithm is running on the data to create a model. So from the model, you train and you test it. And when you deploy it as a web application or a mobile application, when new customer comes for the same product, they just feed in the data. And with the learned patterns, the algorithm is going to respond to the new data set. All right. So it composed of both data and procedures. Right. So when you take machine learning model, it is a model of data plus prediction algorithms. All right. So an algorithm here we say model. You develop your model of machine learning model to use data and for prediction of new data. All right. And then what are the major steps in developing a machine learning algorithm or a machine learning project, or it have to be a machine learning product? First, you have to define the problem. So from this data set, can you tell me what is the problem that I would find? Even for the next new customer, if the patterns are like this, whether my opportunity is going to be win or loss, right? Whether my opportunity is going to win or loss. That is what we are going to see. All right. And then you have to prepare data. Then What is the data set? Now I've taken a bench. Whenever you work with machine learning algorithm, you need to work with benchmark data set. What I've taken, what's in sales analytics, like, so that's a benchmark data set. And how are you going to evaluate algorithm? There are plenty of evaluation metrics. And then how will you improve the results and present results, right? Using hyperparameter tuning. So the first skeleton of first installing Python and SciPy platforms, loading the data set, summarizing, visualizing, and evaluating, and making some predictions. Right? So these are the different headers I've taken: opportunity number, supply subgroup, supply groups, region, how it is being routed to the markets, right? How elapsed stages in sales stage, what is the opportunity? So this is my target value, right? You can see here, this is my target value. So whenever it is a target, what it is? It is a classification model. It is a classification model. How many sales stage count? There are 19 columns, right? Every column that is as it is given here. So I fetch the data. We need to curate the data. That's very important. I told you, right? Even one missing values, you will not be able to develop a machine learning algorithm. If there is junk value, say for example, listen very carefully. If you're going to take data directly from the sensors or from the satellite, sometimes it is possible for you to get some junk values. So you need to split it up and curate the junk values. And converting categorical data to numerical data, because a machine learning algorithm cannot understand strings. Say for example, traffic, you have got different signals, right? Orange and green. And I can map it to red to 0, orange to 1, and green to 2. All right, green to 2. So that's the first step, and then we can move on for feature extraction and normalization. How am I going to transfer it? And then what are the different pre-processing that I'm going to do? And exploratory data analysis, the machine learning algorithms after analysis. I'll be splitting my data set into training and testing. Right. So moving on to our algorithm, our computation here, right? I have told, right, head of function, then tail of function. Head of function gives me the first few rows 5 by default, tail the last few rows. So this is an attribute. Whenever I don't have open and close parentheses, it is a pandas attribute. When it is open and close parentheses, it is pandas methods, right? So these are the different columns available, right? So if I want to know the data type of each, I can see opportunity number, the data type is integer, right? When supply subgroups, it is object. Can you see here? These are strings. I told you machine learning algorithms cannot understand objects or cannot understand strings. So here in machine learning, we have a package called as label encoder, where it finds a unique number of unique variables in supply groups, supply subgroups, region, routed to market, opportunity to sell, right? Only those things, right? For that, it will map to a numerical value. After it computes a machine learning algorithm, you can, after you encode it, you can also decode it. All right. So let's see how it is going to work. So, and others are into integers. And describe of, right? It is the descriptive analytics. You remember I spoke about descriptive analytics. All right. It will take, all right, the unique values here. All right. And then it will try to compute, all right, how many number, is there any missing values? No, there is no missing. And also this describe of function will work only for integer or float. You cannot see the supply group, supply subgroups here, because it is of type objects, right? The mean, what is the standard deviation, what is the minimum, what is the maximum value, and so much and so more, right? So the minimum sales stage count is 1 and the maximum sales stage count is 23. Right? This is an example of descriptive analytics. It takes the mean, the standard deviation, minimum, maximum, top 25%, 50%, and 75% of data. All right. And then when you move on into it, to now find number of unique values, right? The sales data, number of unique values. So we have got 77,829 unique opportunity number. Right? How many supply groups are there? 11 supply groups are there. Right? So these are categorical values. So you need to convert all the 11 into normal numerical values using label encoder. Alright, so supply groups are 4 and region, how it is routed to market, it is 7. You remember these 4 are objects, which is strings we need to convert to categorical value. And also this opportunity result is only 2. What is opportunity result? Whether it is won or loss. So if I want to know what is a particular region, here it is showing, right? N unique will tell me the number of unique values. If I want to know the unique values, for example, of region, sales underscore data, that variable I have loaded my data set of region of unique of. Here it is N unique of. Here if I am going to give unique of, so I will know what are the 7. Northwest, Pacific, Midwest, Southwest, Mid-Atlantic, Southeast and Northeast and Southeast. And the data type is objects, right? Number of unique values is 7. So if I want to know the number of dimensions, it's a 2-dimensional data x and y. So I'm getting n dimension. And what is the axis? Only 2 axes. X axis 0 to 78,025 and y axis the 19 columns, right? And what is the values already told you. Right, and coming on to the minimum value, what we have done, and the maximum value, individually also I can try it. Right, in describe of, it takes the entire computation of minimum, maximum, top 25, top 50, top 75, standard deviation, median. And if I want to know about the individual column, mean, median, mode, that also could be computed. These are all the things that comes under descriptive analytics. If you want to know the kurtosis of the value, then I can find skewness in general or in specific to one particular column also. And these skewness of data and kurtosis of data will work only for integer and float column type, not for object. Alright, so I told you, right, when we use pandas, I can find missing values, and we are fortunate this data set does not have any missing values. So data set is sales underscore data dot is null of dot sum of. Then it finds there is no missing values. All right. And so supply groups, what are the different 4 was there, right? Car accessories. What are the car accessories? Performance and non-auto, tires and wheel, and car electronics, right? And car electronics. These are the 4 supply groups. Inside each supply groups, we have got a supply group, we have got supply subgroups. So it is exterior accessories. If you come into car accessory, motorcycle parts, shelter and RV, garage and car care, or batteries and accessories, or performance, or tires or wheel, or interior, or car electronics, or replacement, or towing and textures. So through which region and how these products are routed to market? These are routed to field sales, that the field people, they go in for sales, or it goes to a reseller, or it goes to the tele sales or tele coverage. All right, able to understand till now? All right, all right. And so when I move down, I can use different slicing operator, row slicing, column slicing, and row and column slicing. All right. So X is equal to, I'm giving my opportunity result. So what is my opportunity result? It is win or loss, right? So here I can see in this data set what I've taken. The loss is more in comparison with the number of people who have won. then I can find how this product is routed to the market, right? So how this product is routed to the market through the field sales, to the reseller, very minimum it is routed to others route to market, telesales and telecoverage, right? In this field sales, if I want to find how many opportunity won or lost, okay, I can give as X is equal to how it is routed to market, my data is my data set, and Q is my opportunity result. So here I'll be able to find. So I could find through reseller, I've got a maximum profit, and next comes to field sales. But the loss is more through the field sales. So these inferential analytics statistics is more important when you come into before you develop a machine learning algorithm. It is not only knowing how to develop machine learning algorithm. You have to understand what are the features that is enhancing, what it is supporting to it. All right. And this is how I can see, right? Reseller has best profit, heavy losses through the field sales. Likewise, I can work with different plots like visualization. Before you start working with an ML algorithm, this is an example of violent plot. All right, how it is rooted the market, client size by revenue. And before you start developing, you need to particularly analyze your data, how it works on, right? So the way it works with your kernel density estimate, right? And also heat maps, you can work with heat maps, and it will know which has got the highest correlation, right, with the opportunity number. And then I will let you, as we have got lesser time, I'll tell you how to, so from sklearn, I'm importing label encoder, and I'm encoding by supply groups, region, router to market, opportunity result, competitor type, and supply groups. All right, and how many unique values are there? And then I can, once it is done, then I'm putting onto my fit transform. Now you can see according to the number of supply groups and supply subgroups, how it is region to market, it is all labeled encoded, and opportunity result is 0 and 1. Loss is 0 and 1 is 1, right? And from this, I'll be splitting my data set into my data and my target. And then a target is my opportunity result, right? Target is my opportunity result. Then I'll be developing my training and testing data set. And then once I split my training and testing data set, then I can use any different algorithms. So I'm using Gaussian A-base, and the performance metrics is accuracy, it is 76%. You can see here, if I'm going to use linear SPCE, and accuracy is how true positive from my training and when I give my testing, I don't give my target, right? And then I can see out of these three algorithms, it is 76%, linear SPC is 77, and K-neighbor I'm getting 81%. Not only this, you've got different metrics. We work with like 12 metrics, like Computational Intelligence Research Foundation we work with the research and development, education and training. You can visit our company's website, right? And this is our website, cirf.co.in. We'll play the live quiz for just for 5 minutes, 5 multiple choice questions, right? And we work with research and development. You can see the list of events that we have conducted, and we are in the process of conducting. All right. And then we have 1 week online internships for students online, 7:30 to 8:30. At the end, the students will develop a project of what is taught for them. If you're interested, or if any of them are interested, you can share it with them. And for summer internship, we are providing 20 hours of sessions, right, on 3 batches on cybersecurity and data sciences. And it's a Section 8 company. The certificates that you get will be valid. And you can see what are the other projects and what are the other products that we are developing here at the CIRF. All right. Now let's play a live quiz. Just type menti.com and give the voting code 29624576. You have your mobiles or systems, just type menti.com and the code is 29624576. Is the screen seen? Are you all joining? This is the meet code, menti code. Kindly join quick. Yeah, I've got one player. 2. We have got 60 plus participants. 63. It does not need any registration or anything. Just type menti.com and the number is 296245. I have not started it. We'll start soon. At least a few of you, if you join, it will be interesting. Yes, 5 of them have joined. What about others? Will you be joining? Only 5? What about others? We have 60. Only 10% have joined. I wish everybody to join. Is it easy or is it challenging for you to join? Let's be quick. What about the remaining? Because it is online, I don't know whether you are really listening or just a blog. I know your professor has shared a lot of pictures of how are you listening to the session. Yes, please. Okay, only, yeah, 7, 8. Let's start. Others could join. Please do join soon. Which tool is used to generate charts? NumPy, Pandas, or Matplotlib for generation of charts? Seven of them have joined and 7 if you've given the right answer. Others also could join. You can see I've shared the screen. You can see the code. I don't know who's Venture, Blade, some names that I've given. Give your names properly. And the first place is Venture and second is Blade. I know it is not your correct name. You can edit your names, yeah. Let's see now. Which function is used to find the number of rows and columns? Shape, size, or type? Number of rows and columns. 8 of you have given the answer. The right answer is shape. Size gives you rows and columns multiplied. The total number of cells. Okay. Shape gives you number of rows and number of columns. I can see one name, Akleshwar Reddy. On first is Reddy, second is Ananya, third is Annie Droid. I don't know. You can change it. Let's move on to the third question for the day. I wish others also to join soon. What is the data type of the data once loaded into data frame? Is it CSV or data frame or TSV? I told you during the session. And the right answer is data frame. Any type could be the data. Once I load it into a data frame, it becomes, so once I load it into a pandas, it becomes data frame. Let's see who's on the first. Ananya. Akshat Khan Venture. Android has changed the name. Oh, is Akshat. Right. Congratulations, Ananya and Akshat and Zaid. Let's move on to the fourth question of the day. Prediction model is developed by who develops the prediction model? Whether it is data analyst or data scientist or none of the above. Who analyzes, develops the prediction model, or who data scientist develops the model? Think and answer. Okay, the right answer is data scientist. Data analysts, they work with analysis of data, but prediction model will be developed by data scientist. 3 of them have given the right answer. Zaid, Danishwar Reddy and Bharat. Let's see who's on the first. Zaid, Ananya and Akshat Khan. Congratulations. Let's move on to the final question to know who's the winner for the day. Which Python package provides machine learning algorithm? We've seen a lot of Python packages. It's NumPy, Pandas, or Scikit-learn. Which Python package provides machine learning algorithms? Wish most of you would have joined the session. Yes, it is Scikit-learn. So let's see who's the winner. And the winner is Zaid. First place, second is Ananya, third place is Akshat. Congratulations, winners. You can unmute your mics and share your experience of how the session is all about. Was it useful? Did you learn something new? Yes? And also you can, thank you, thank you. And also you can watch onto my YouTube channel and almost the sessions that I come on online, I host it onto my channel. I can see on this when this session is available. If you are interested, you can figure it out and find it. If you are interested, you can subscribe to the channel so that it will be useful for you of different talks that we give on. All right, and this is our company's website, cirf.co.in. You can find any information about other services that we're providing for students. And if it is usable for you, you'll be able to connect with us. All right. Hope the session would have been useful to you. Some of you have given, it's very informative, interactive, algorithms were good. You learned something, you like the way you have the quiz at the end. Thank you so much. Thank you so much for attending the session. This is the contact details. You can reach out to us. Oh, to the organizer. Thank you, Professor Sudha. Thank you. Thank you all. Bye-bye.